Good morning to all of you. Shall I tell you a few things where you have got confusion in your mind?
Yes, sir.
Okay. I've corrected almost all the papers. I don't know whether I should give it to you or not. I'll ask Nikhil about it. Basic problem is that you seem to have difficulty in set theory. That is my personal feeling. You have difficulty of understanding what is domain and what is range. I don't know whether I'm correct or not. Am I correct? Shall I explain what I am saying?
Yes, sir.
I'll just share my and then let you know. You have any questions?
No, sir.
Tomorrow you have Friday class time.
Yes, sir.
I'm switching off the camera because of the bandwidth. Okay, let me give you discuss the question. We're talking about some warm up. I'm setting up the tablet, Macom tablet. Okay, so this is warm up. So the question in the exam was that for f in L2, zero one, define t. So let me call this as x. T on x by for f in f, define tf. What is this tf? It is defined on L201. That means we have to give the value of tf at x. This is defined as 0 to x S Fs ds. Question 1, is it defined? I mean, you have put the definitions, okay. Is it well defined? What is the meaning of well defined? Well defined means for each f in L2, this integral should be finite. Nobody has verified it. Huh? Okay. This integral exists, but the value may not be finite. For example, S is continuous, F is in L2. Is it necessary that S into Fs should be in L1? You understand the point, no?
Yes, sir.
You see, I hope you understand what I'm saying. Take, for example, F equal to, let's take, say, root S. Huh? Okay, root S. Is it in L2? So integral mod f squared ds should be finite. This is nothing but integral is 0 to x, okay? This is nothing but s ds. Is it not finite? In L2, right? Now what about 0 to x, s of s by root s ds? This is nothing but 0 to x root s ds. Is it finite? Is it finite or not? It has to be proved, right? Why this integral is finite? Huh? What is integral root s?
Sir, 2 by 3 s power 3 by 2.
Huh?
2 by 3 into s power 3 by 2.
S power?
3 by 2, sir.
Is it finite or not?
Finite, sir, if our s belongs
So
to
that
this.
has to be checked, right?
Yes, sir.
That's what I'm saying. So this root s, so now if you take this TF, now you look at this TF at x, modulus of this. This is nothing but integral 0 to x. So it will be less than or equal to, all right. Mod s fs mod fs ds. Now how do you know this is finite? Huh?
Integral values are less than infinity.
This is in L2. This is in L2. So integral fg is in L1 by Holder's inequality. So this is finite by Holder's inequality. Is it clear?
Yes, sir.
So what it says is this TF is well defined. What is the next question? It says show that T maps L2 to L2. That means you have to show that this TF is in L2. Right? What people have done to show that this is linear, they have taken TF at x1 plus x2 equal to integral x1 plus x2, whatever it is. I don't know why this should be less than or equal to 1, because the definition is on 0, 1. Say take x1 equal to 3 by 4 and x2 equal to 3 by 4. If you add it is 1.5. This may not be in the domain. So this answer is wrong. Second thing is, you have to verify this T as a linear map on L2, not on R. You are verifying here on R. That is not what is asked for. You are asked to show it is linear on L2. What does it mean linear on L2? Take T of F plus G, show that it is TF plus TG. That is to show that this is how you should write the answer, right? So T of F plus G, by definition, at X is integral 0 to 1 S F of S plus G of S ds. This integral is linear, therefore this will become TF at X plus TG at X. So TF plus X at TGX is 0, therefore it is true for all X in 0, 1. Therefore, T of F plus G is TF plus TG. Clear? Similarly, same thing. Therefore, it shows that this T is linear. Dot, 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 dot. Is it clear?
Yes, sir.
Okay. Second question is that you have to show this T, 1 minute. This TF is in L2. That means what? You have to calculate TF at X mod square integral 0 to 1 finite. So calculate one after the other. So step 1, mod TF at X is less than or equal to integral 0 to X S mod Fs ds, right? By holder, this will be less than or equal to, so this is in L2, obviously. This is in L2 given. Therefore, this will be less than or equal to the L2 norm of S into the L2 norm of F by holders. Actually, here you have 0 to X, but now I raised X to 1. Okay. Now this is finite. Therefore, you take the square of it. Okay, you get a square of this. You get a square of this. Integrate mod of T of Fx square. You have to show this is finite. You have to come to this step. This will be less than or equal to, this is a constant. So it will be constant times integral 0 to 1, 0 to x, norm f squared dx. But this is anyway constant. So this will be less than or equal to something, norm f squared into some constant k. Yeah. But this is nothing but norm of t of f the square, that is less than or equal to m times norm of tf square. Therefore, norm tf by norm f is less than or equal to m. Is it clear? Therefore, t is continuous. This is what I wanted to tell you. You seem to have forgotten that the domain of D is L2, not 0. That was the problem. Okay. Same way, other question. Take F in L3 or I don't know what it is, X in L3 or something. And then you look at the summation mod Xn n raised to minus 2, n equal to 1 to infinity. This was something, Fx or something like that. Show that F belongs to L3 star. What does it mean? That is to show that F maps L3 to R, F linear, and F continuous. The problem with most of the answers is you don't write this step. So you jump somewhere. For example, somebody says that this summation mod xn square n raised to minus 2 is finite. Okay, this is okay. But this is not asked for. You have to show the norm of f, okay, as an element of L3 star is finite. Not this. These two are different. Is it clear?
Yes, sir.
So my simple question is, why are you in such a great hurry in writing answer? And what makes you to write something which you don't know? Some person writes that the summation xn into n raised to minus 2 is in L infinity. Did I ask you that it is in L infinity? Is that the question? Somebody writes this series is bounded. Is that the question? The question is, you have to show that as a map on L3, it is linear and continuous. So you don't write, this is what we have to show, this is what is given to us. This is, see, when you are doing geometry, before 12th standard you came, what was the thing that you wrote? Hypothesis, okay, construction, and then the proof. You don't write hypothesis. You have to say what is that you want to show that. You don't write it. Simply write some answers which are totally disconnected. Now my question is, why do you write disconnected answers? I told you in the very first class, even last year also, if you don't know some step, don't write. Why I am saying this to you is that if you get used to this, you cannot come out of that. Our job is to make sure that you think logically, you write logically, you prove things logically. When you take up a job somewhere, if you do hodgepodge, work like this, you will be thrown out of the job. Any questions you have? Feel free, yeah? What is the difficulty in writing proper answers, huh? Can you answer 4 questions properly in 1.5 hours? What was given? Can you or not? Hmm?
Yes, sir.
If you can write 4 questions properly, you would have got 40 marks, no?
Yes, sir.
It's above the average. So my question is that if you have any difficulty, please let me know. What is the difficulty you have? If you bunk the class, I can't help. Huh? Okay. Feel like what is your problem? Huh? What is your issue? All of a sudden you jump off somewhere in your answers. Huh? My sincere suggestion is that you please take half an hour or 1 hour and please read the basic set theory which you are missing. I think nobody has taught you. So what I have told your director is that the first year student should be taught basic set theory, before they start the classes. That is an issue that you have. Second issue, which I am guessing, if you are asked to state Hahn-Banach theorem, what is that you should say?
That is statement, sir.
A proper statement, no?
Yes, sir.
There is
Proper
a
statement.
non-linear space, there is a subspace, there
Yes,
is a
sir.
functional on the non-linear subspace, then it gets extended. If you want a separation theorem, you write the separation theorem also. You have 2 hyperplanes given, then there is a functional on X such that the two hyperplanes are separated. You don't write anything, huh? No non-linear space, nothing. There is no functional in the thing. It is written like a story. This is not a course on, English language or something. Please note that. So when you are asked to give a statement properly, you write a proper statement, mathematical statement. Why these exams are conducted? It is conducted because your mind has to be disciplined. We are not worried what marks you get. At least I am not worried what marks you get. But your mind should be disciplined. You should have a very clear discipline. I will not write if I do not know the answer. That amount of honesty should be with you. Then only you can get along, quite a bit. Otherwise, it can be a little tough. See, what happens is when things become tough, then you get frustrated or you get disinterested. Oh, this is a lousy thing. Right? Then you don't study that part. And then it creates a serious headache. That's what I am a bit worried on that. Bandwidth little less, so let me switch off the video. Please feel free if you have any comments to make. Otherwise, I'll continue with the lectures. Sonam Kumari. प्रज्ञा,
Yes, sir.
आपको दिक्कत क्या होता है यार? आंसर लिखने में दिक्कत क्या होता है आपको? सौरभ, त्रिलेखा, Anish. Kush. Some three others. I don't know who are the three others.
So it's very difficult subject for me, sir.
Huh? Kush.
Sir, it's very difficult subject for me.
If it is difficult, you have to tell me what is the difficulty you have. I can clear your difficulty if you tell me what is your difficulty.
Everything, sir, like reading those mathematical notations, writing the proofs, sir, everything is difficult for me, sir.
Why you don't know how to write a proof?
Yes, sir.
Huh? Have you not written proof in 12th standard for geometry problems?
So we have written, but sir, it's still difficult in functional, sir.
But you don't write the steps, no? This is the hypothesis given to prove that. Did you write like that?
Yes, I try to write like that, but sir, I don't know where to continue. That next, what would be the next step? I write proof, given that. After that, I don't know what to do, sir.
Okay. But in every class, I asked you, do you have any questions to ask? You should have asked me, no?
Because everything is out, sir. What can I ask, sir?
Rishabh,
Yes, sir.
as a class representative, I request you to find out from your friends
Okay, sure, sir.
how I can help all of you.
Okay, sir. So some of saying, sir, if you write, sir, like using that mouse as whatever, that not look properly, sir.
Hmm.
Like when we attending the classes, that time we can understand. After that, if we see the notes, that will be not like, sir. Some terms we confuse, that is L1 L, like that, sir.
Is it confused or is it that you have not understood it properly?
Sir,
There's a difference, huh?
yes, sir. Sir, I'm saying that, sir, whatever notes you have sent us, sir, that in that notes, sir, sometimes, sir, mm, didn't look properly. That's why, sir, we confused. Like when we attending the classes, that time, sir, we understood, sir. After
Then
when
you
we,
immediately go home and write the notes.
no, sir.
If you don't write the notes, you'll forget it.
Yes, sir.
Hmm. And if you are not able to write the notes, the next day I ask you, do you have any questions to ask? You should ask me. Right?
Yes, sir. Yes, sir.
I will again explain to you what is the issue. The issue is you seem to have problem with set theory. That's what I'm worried about.
Yes, sir.
I'm not saying anything else. Huh? I'm saying there is nothing very difficult about it because everything I have done it. Done it in that class.
Yes, sir.
I will again show you the same story. Okay, 1 minute. Huh? I will write each step and you tell me what is the difficulty you have. Okay, one of the question, simplest question which I have done in the class also, that this x is in L3. N equal to 1 to infinity for x in L3, right? What is that you have to show that f is in L3 star. You write like this, no? What is your issue, huh? L3 star. That is as good as showing f is linear plus continuous, right? What do you mean by continuous? The norm of fx is less than or equal to some constant times L3 norm of X. Yes or no?
Yes, sir.
You don't write this step, no. These things you don't write. You are not knowing where to go and what to go. Kush, this is what I am telling you. Were you not writing this in the 12th standard? When you are
So we
doing
were
all
writing so like this.
yeah, but what is wrong in writing it, huh? So how do you calculate the norm of fx? So norm of fx is actually the modulus of whatever that stuff. Okay, this is in this f is a map from it is in L3 star. So L3 to R. So you have to calculate mod of fx something, okay, into some m times norm x3. You should get this norm x3 here, and then you divide mod of fx by norm of x3, correct? Yes or no? This you have to calculate, this will be less than or equal to m. Then this implies f is in L3 star. Is it not, Kush? So
Yes.
you need to get this L3 here. So you have to get this mod of fx less than or equal to something into norm x3 L3, correct? That is to show that. I am not showing anything now. I am only writing what is to be done. You don't do this work. That is the problem. So you calculate mod of fx. That is actually nothing but less than or equal to summation mod xn. I am telling you how to write an answer. N raised to minus 2. Okay. What is that you know here? I want x3 out here with the norm. So this I want to be norm L3, this L3 or L3 into some constant here. How can I get this one? So if A is in LP, B is in LQ, I have done this in the class, right? 1 over P plus 1 over Q equal to 1. Then AB is in L1. This we have done it, right? And not only that, the summation AIBI, is less than or equal to the LP norm of A into LP norm of B. Don't do anything. So I want this with 3 norm here. That means P is 3. Is it not? That means what should be Q? So it is 1 by 3 plus 1 by Q equal to 1. So what is Q? Quickly tell me.
So 2 by 3, sir.
2 by 3. 1 by Q, no? So Q is 3 by 2. So you have to show this n raised to minus 2 is in L of 3 by 2. Show it. How many steps are there? Okay. First step, 1, 2, 3, 4, 5. Is this in L3 minus 2 or not? N raised to minus 2. Okay, you take the power. So summation n raised to minus 2. You have to raise it to this power, right? This is nothing but summation n minus cube, right? This is finite.
Yes, sir.
खत्म हो गया बात. इतना करना नहीं आता है क्या? खुश। इसमें क्या डिफिकल्ट है यार, हमें समझ में नहीं आ रहा है। Tell me, Kush, what is the difficulty in this place? Huh? आप इतने जल्दी लिखते हैं, you don't even write what is to be proved, how is to be proved. Everything you know, but you don't know how to write. That is my problem. Pratnya, is that true?
Yes, sir.
You know it, but you don't know how to write it. Sri Lanka. You know everything, but you don't want to write. Why? Take it. Enough is enough, all right? What I am saying is, life is something which you should not worry. Life is not like a cassette. You can't rewind it. जो हो गया, खत्म हो गया. Let me tell you a small story. Rishabh, you want to a small story for 2 minutes?
Sir, which motivates us, sir?
It motivates me also, not only you. You know Euler's theorem, you know?
Yes, sir. Yes, yes, sir.
Once he had problem in seeing, so he went to a doctor. Doctor told him, you are going to lose your eyesight in 2 years. Right? All through the life you had the eyesight. Now the doctor says we are going to lose it. Okay? So what he said is, no matter what has happened, forget about it. Let me work from now onwards. So what he did is, he went home, he said, thank you very much, doctor, that you have given me 2 years. I will go and start writing, closing my eyes. So he started writing theorem and proof, closing his eyes, and opened his eyes and verified it for 1.5 years. Then he learned to write proof without seeing what he has written, because he has no eyesight. And he wrote 5 papers after he became fully blind. 5 research, totally blind. And 1 paper has a citation of something like 25,000. You know, this citation 25,000 is a very high number.
Sir, what is citation 25,000, sir?
25,000 people have used it in their research paper.
Okay, sir.
He did not worry what had happened till now. He was worrying what we should do now. That is what I am telling you. Don't worry what you did or what you did not do. From now onwards, do it properly. Don't go after marks or grade. Go after the subject. If you go after the topic, your only friend for you is logic and reason. Nobody else is a friend for you when you are writing an exam. Anything that you don't think and write, then you may get into problem. That is why I am saying, if you don't know something, don't write without a proof. If you know the proof, you write it. Otherwise, don't write it. This is my sincere suggestion. You see, the problem, I don't know whether you see it or not. When I am teaching a class like you, I look upon all of you as my children. And therefore, I don't want any of my children to commit a mistake in life or in exam. I will go all out to help you out, to make sure that you are in the right track. It is my full effort that I will give it here. Now, it is for you to act. Whether you want to act or not, it is left to you. You see, I can give you a gulab jamun. Whether you want to eat or whether you want to throw it, it is your choice. यही कह रहा हूं. ठीक.
Yes, sir.
I have slightly changed the way of lecturing now, slightly. I used to teach from a book, right, or notes. The unfortunate part is that book or notes you may or may not have. So what I am doing is, whatever the lectures that I want to make, now I'll prepare a small notes and send you that notes. Whatever the book I'm going, I'll just take a copy of that one, put it on the PPT and send it to you. All right. So that you have the material with you.
Okay, sir.
Finally, any questions?
No, sir.
Okay. I will share the screen and start teaching the class now. Okay.
And sir, please send the today's writing notes, sir.
Sure.
Thank you, sir.
Definitely I'll send it. I'll share the screen. Just a minute. Can you see the screen?
Yes, sir.
Okay. This is the notes which I have prepared for you. I'll send these notes to you today. This is the open mapping theorem. Now I saw 3-4 books, but this note seems to be this proof seems to be very simple. So I am giving this proof of the open mapping theorem to you. This is from the book of Kreyszig, Functional Analysis. Okay. All right. So definition of an open mapping. So let X and Y be metric spaces. dt means domain of T. Okay. So this T has a domain of something, a set in X, such that it's a map from dt to Y. Do you understand this or not? Huh?
Yes, sir. Domain means a subset, something like that.
It is on the set on which it is defined. Shall I give an example?
Yes.
Okay. Take C01. Take X equal to C01. Let us look at the operator d by dx. Differentiation. Okay. What's the domain of T? What is it?
Domain of T.
F, such that F is differentiable.
Yes, sir.
So this domain of T now, so will be a subset of X. It won't be whole of X. Is it clear? समझ गए ना?
Yes, sir. Yes, sir.
So unless the function is differentiable, this T cannot operate. It will operate on only those functions which are differentiable. But every differentiable function is continuous. So domain of T will be strictly contained in X. X is nothing but continuous functions. That is what he says here. So T is a map from the domain of T into Y. Right? With the domain contained in X is called an open mapping. If every open set in dt, please note every open set in dt, the image is an open set. dt is a subspace of X. So this openness in dt means it's a subspace topology on which it is open. Okay. So I will not give the details here. There is something here which we can see here. Okay. That is the basic definition of the open mapping theorem, bounded inverse theorem, one of the most important theorems in functional analysis, most useful in numerical analysis, applied numerical analysis, etc., etc., etc. That is why I am trying to do this theorem. A bounded linear operator T from a Banach space X onto a Banach space Y is an open mapping. Okay. So hence, if T is bijective, then T inverse is continuous and thus bounded. All right. That's what the open mapping theorem. And so what it says is, if a bounded linear operator is onto a Banach space, the map has to be onto map, surjective. Then it is open. Then it's an open map. Okay. Let me explain to you in a minute. Okay. X is a Banach space. Y is also a Banach space. T is a map from X to Y onto. This is important. That is Tx equal to Y. Then T is an open map. So this onto-ness implies the openness. That's what the theorem is. So a bounded linear, it's a bounded linear operator and a Banach space X into a Banach space. See, please note in the uniform boundedness principle, we had domain space to be Banach, but the range space need not be Banach. But if you want to get some result, then you need stronger conditions. Okay. So what it says is, if both range and the domain are Banach spaces, and if the map is onto, then it is an open map. If it is bijective means the T is linear and also one on onto, then T inverse will exist. If T is an open map, then T inverse is continuous. So that's what the second part is. This is called the bounded inverse theorem. The proof of this theorem is slightly longish but not difficult. Okay. So here he explains the notations that he is using the book. This I have given you. Okay. A subset A of X, we write alpha A equal to alpha times scalar. Okay, some element. A plus W means that alpha A is alpha times A. A plus W means set of all X in X such that X will be equal to A plus W. This I have explained to you already. This is something that he gives it in the geometrical definition. Okay. So since T is surjective and linear, this T will be equal to Tx. This is the meaning of saying it is onto. This will be T of union K equal to 1 to infinity KBI. Okay. So KB1, let me explain to you a bit more. Yeah. This you have to understand this point here. Okay. A bounded linear operator T from a Banach space onto a Banach space, and Y has the property that T be not of the open ball B not equal to B01 contains a open set. This is the statement. Now there are some notational things here. What he writes is that we are going to prove this theorem in a step by step. The first thing is that we denote the ball B1 to be a ball of radius half around 0. Ball Bn means ball of radius 2 raised to minus n. Okay. So B1 means it is just B0 means it is just ball of radius 1. Okay. So here it is written here, the unit ball B0. B0 is the ball of radius 1 with center at 0. So this B0 you have to understand here. That is what so this theorem is split into two parts. First you prove this lemma. All right. And the lemma So this lemma we are going to prove it. To prove this lemma, we need this notation. This notation is that I have given it to you earlier also. Okay. Now this T is surjective and linear. So what do you mean by subjective? The range of T is whole of Y. That is T of X is Y. That I told you in a minute back. But this Y, you can write it as union of KB1, okay, from I k equal to 1 to infinity. The whole space X can be written as the union of, what it simply says is the following. The space X here, the space X here is nothing but union of K times B1 or B0. K equal to 1 to infinity. This is the thing. What is this K times B1? B0 is ball of radius 1. Okay. What is K times B1? Yeah. What is this?
Ball of radius k.
Very good. Ball of radius K. So we want to show this. Don't take anything for granted in your life, okay? So what does it mean? We have to show that X is contained in this set. Second, you have to show that this union K equal to 1 to infinity, KB0, okay, is actually contained in X. This is obvious. It cannot go out of X anyway. So you take any X in X. Now you divide X by norm X. Then this becomes this Y, if you call this as Y, then this Y will be norm 1. So for this given X, this Y will be in B0. Okay. Now what you do is you take this B0, this norm X is a finite thing. Therefore, this will be norm X will be less than or equal to some K integer. K in integer. Okay. So now therefore, if you look at this K times Y, this will become an element of K times B0. Therefore, this X, okay, this X will be in K times B0 for some K. Therefore, this will imply this X is in union of K equal to 1 to infinity because it is in some K B0. Therefore, union of K B0 is obvious, huh? It's X. That's the proof. It's not given in the book, but I am giving you the proof myself. Okay, that is what is written here. This is what is written. Now you can use the linearity, etc., etc., etc. So this T of KB1, this K you can pull it out and you can take the T inside. And then you get, this is nothing but K equal to 1 to infinity, KT B1. This is nothing but K equal to 1 to infinity, KT B star. That's obvious because you said A closure contains A. Right? This is nothing but A closure. So, I mean, what I am saying is that you know it, okay, I'm just writing it. For any set, A is contained in A closure. That is what is used. Nothing more. Okay. So that is the, so you have this Y to be union of K equal to, it's a countable union of KTB1 closure. Now taking the closure, etc., etc., etc. And since Y is complete, it is it has to be a thick set. It cannot be a meager set being there. So by Kerr category theorem, by whatever the base category theorem that we have done earlier, we conclude that KTB1 for some K must contain an open ball. The interior of Y is not empty. The interior of Y is not empty means there's an open ball contained in Y, and therefore it will be in some KT1 V1. Okay. So it is 12:52 in my watch. I will stop for a while here and continue with the lecture on Thursday. I understand that tomorrow's lecture is Friday's timetable, but I don't have a class on Friday, so we don't have a class tomorrow. I would like to ask you last simple query. Did you get hurt if I say that this is not the way you should write? आप लोग को गुस्सा हो गया क्या?
No, sir.
All right. Second thing, Rishabh, last time I was told that some of you wanted to have lunch with me or dinner with me. But I could not find time last time because it was Ekadashi.